on any Raspberry Pi, you can get it to control the LEDs on it. So that's a program written in C using a thing called wiring Pi. So how many people have played with Arduinos at all? Okay, so a lot of you. So wiring Pi is basically the same programming interface as Arduino, but for the Raspberry Pi. So you can change a digital I/O by saying, out, or whatever it is, output, or I can't remember now. digital write. Same idea. However, even if you don't want to do that, the Linux operating itself provides access to I/O pins like that. So let's see here. If I can go back here. So here's an example. So if you wanted to manually turn something on, you can there's these 3 commands. The first one here tells the operating system to allow you to work with a particular I/O pin that's on the device. The second one sets it as an output so that it can drive the pin one direction or another. And then the last one actually sets the value, so whether you want to turn it on or off. So as an example, I'll select this. It's interesting. I really should have mirrored these. Mirrored my display. This is terrible. So I'll send that one real quick. Sorry, my copy and paste didn't work too well here. Flash, GPIO, export. Okay. Well, I might need to skip this because this is kind of hard to do here with the. At any rate, the point is, you don't even have to know programming or anything to control pins and stuff on there. You can just directly access devices that are on the system. So, the last thing, just to kind of show how my application with my dissertation work running on there. So this is a video kind of showing. I'll do one more thing. Sorry. Go back here to that. Okay, so this is to get a little description of what's going on. So in my simulation, each node on the Raspberry Pi represents one node in the sensor network, and the distance that any node can communicate with any other node is controlled by the simulation. So this is this thing on the side here, just showing the radius that any one node can talk to another node. So for instance, if node 1 wants to talk to node 32, it can't do so directly. It has to send messages to all the nodes in between. And really, it can only talk to node 2 or 5 in this example. So what I did is I set up my simulation so that whenever one of these nodes sends a message, it lights one of its LEDs on the cluster, so you can actually see when a message is sent across in the simulation. You can see it move across on the device. So now I have a little video to do this because it is a little bit cumbersome to set up initially. So it goes through various stages. The first thing it has to do is establish a network, because since they can only talk to the node nearest them, it has to establish a network. So what you're seeing here is discovering where all the nodes are in the network, sending messages back and forth. And you see it kind of growing from the top down. That's node 1 started everything, and it's discovering where all the other nodes are in the network. So once it's established a network, then it starts sending messages to each node in the network. So in this example, you'll see packet. Node 1 at the top left is going to send a packet to every node in the rest of the system. You see kind of it go down different paths as it makes its way to their target destination. So whenever the light's green, it's receiving or sending something. Whenever it's red, it's receiving something. And then the last phase is a broadcast message. So node 1 sends a broadcast, and that propagates through the rest of the network. But this whole time, it's happening by hopping hopping through the network. All right. And lastly, so give an idea of what was all involved with building this. I kind of have a bill of materials that was involved in creating the whole thing, and basically for a little under $2,000, we were able to buy absolutely everything, put it together. Where you compare that to any traditional Beowulf cluster, you're going to spend at least hundreds of dollars for each node that you want to put together. So it's a pretty good price for the size of the cluster that we have. All right, so with that, take any questions.